In this section, we will begin Chapter 2, where we will start coding programs. We will start by determining what the problem is and then moving on to its algorithmic solution. We will begin by learning how to determine what the problem is, how to determine the best algorithm to solve the problem, and then writing code to implement that algorithm. Some of the topics we will cover are primitive data types. These are data types built into the compiler that it knows about directly. Variables, the idea of areas of memory that remember specific values. We need to have a way to remember things as we solve problems. We will determine results and remember those for later use. Constants are similar to variables in that they have a value, but unlike a variable, a constant does not change its value. Once assigned a value, it remains there. Operators are symbols, usually, that represent things we can do with data. You're very familiar with them in arithmetic. We have the plus sign, the minus sign, multiplication, division. That's the type of thing an operator does. It performs an operation that data gets computed or manipulated by. Operations is that set of things you can legitimately do with the data, adding two numbers or comparing two numbers or looking for certain characters in a string or of text. Does it contain a certain word or something? An expression is something we will cover frequently. It is a grouping of operators and operands. Operands are the numbers or the variables that once the computation or the operation has occurred, there is a value that's returned. That value has a data type. For example, adding the number 3 to the number 4 is a complex expression from the viewpoint of the compiler. There's three symbols, the 3, the plus, and the 4. And the compiler has this driving urge to reduce that to one value, one symbol, and that would be, of course, 7. 3 plus 4 is 7. So it would do that computation and come back with the value 7 and a type integer in this case. It'll become more clear as we use them. Basic input and output. In this course, we will deal with the keyboard for input and the monitor screen for output. Obviously, there are many more complicated input and output devices, but we will stick with the basic ones so that the concepts are clear. Now, solving a problem, we have a certain number of steps, and early in our programming career, it's easy to ignore some of the earlier steps. Problem analysis usually happens rapidly in the brain. We understand very quickly what we need to do. We forget that we actually need to slow down and think about things because the answer appears obvious at first. But if we don't train ourselves to do good problem analysis, we will falter later on when problems become more difficult. Get in the habit now. It will seem like overkill at first, then later on, it'll pay its dividends. This is also true with algorithmic solution. Early on, we often see the steps necessary to solve the problem. Early on, we go for it by writing code first, and it works at first. But later on, we will begin to write a lot of code that doesn't work, and we get frustrated or confused or both. It's only after proper analysis and design of a solution that we should actually sit down and begin coding. Coding is an interpretation or an encoding of the algorithm in a programming language. It's merely an expression of how to solve the problem using this particular language. That should only occur after proper analysis and thinking. And finally, we want to verify that our solution is correct. It's easy to do what's called happy path verification. We run the program, we put in a few numbers that we know should work, it produces the correct output, and we're satisfied. But part of the art of programming is learning how to put in bad numbers and see how the solution works. Does it still succeed or does it fail? And if it fails, does it fail in an expected way or unexpected? And if it fails in an unexpected way, can we change our program, add a few steps to the algorithm to make it more robust so that if bad data is input, then the program handles it in a way that helps the user understand. This and more as we go through chapter 2.